When I first started here 4 years ago, one of the first videos I wanted to make was about thorium-based nuclear power. It was promoted as a safer, cleaner, and more abundant fuel source than the uranium-235 that was powering the reactors of old. But we had to work out some of the kinks. So in the time it's taken me to go from this fresh-faced fledgling, only people could just see how cool it is, to the chiseled hunk of man-meat you see today, what has changed for thorium reactors? In case you don't have time to watch an old video, or if you just don't want to look at little baby Julian with his cute little cheeks, I'll rehash some of the basics of thorium. It's 3 to 4 times more abundant in the Earth's crust than uranium, and when it's bombarded with neutrons, it captures them and decays into uranium-233, which can be used to sustain nuclear reactions. Instead of the solid pellets used in reactors today that need to be kept cool with water under high pressure, fuel for a thorium-based reactor can be embedded in fluoride salts, which melt at around 400 degrees Celsius and double as the reactor's coolant. A molten salt-cooled reactor with thorium fuel in the salt is called a liquid fluoride thorium reactor, or LIFTR for short. LIFTRs would use their fuel more efficiently than conventional ones, would produce waste that's less toxic, and could be designed to shut themselves down safely in case of an accident, preventing a meltdown. The United States pioneered LIFTRs all the way back in the 60s, but the experiment at Oak Ridge National Laboratory was permanently shut down in 1973. So why are we not funding this? Well, nuclear's gotten something of a bad rap, with disasters like 3 Mile Island, Chernobyl, and Fukushima springing to mind whenever nuclear power comes up. LIFTRs would still produce radioactive waste that has to be stored safely somewhere for hundreds of years, and they have their own hurdles to overcome, like finding a material that can resist the highly corrosive molten salts. Thorium reactors also don't generate as much plutonium, which could make it more difficult to use them for building nuclear weapons. That's a plus today, but back when we were building nuclear power plants, we were also building a nuclear arsenal. Because of those issues, progress on developing LIFTRs in the States has been slow. China, however, seems pretty keen on the idea. The country is looking to move away from coal-fired plants that are dirtying their air and has turned to nuclear to cut pollution and carbon emissions. Right now, there are 43 operable reactors in China, with 58 more reactors either currently under construction or planned, many of them breaking ground in 2018 or 2019. With such a big investment in nuclear, it's no surprise they're taking a chance on reviving thorium reactors too. Luckily for researchers at the Shanghai Institute of Applied Physics, they got a head start. Most of the technical documents from the Oak Ridge researchers were posted online for free. Oak Ridge is even collaborating with the Chinese, since many of the original scientists are starting to retire or pass away, and they'd like to see someone pick up the torch. China has thrown hundreds of their own researchers at the project and has made remarkable progress. China plans on investing $3.3 billion to build 2 prototype molten salt reactors in the Gobi Desert by 2020. One will be using solid fuel like we use today, with molten salt as the experimental coolant, while the other will be a full-blown LIFTR with the fuel in the liquefied salt. Scientists from the Shanghai Institute say they've developed alloys and coating materials which solve the major issue of corrosion to the reactor's plumbing. India and Indonesia are also interested in thorium, and in 2017, Dutch scientists came out of nowhere and started the first thorium molten salt reactor experiments in over 40 years, seeing if they could remove noble metals from the fuel to make it more pure and sustainable. Thorium power is just starting to take baby steps again after being shelved for more than 4 decades. The needle has moved a bit since the last time we looked into it, but who knows how handsome I'll be by the time it is fully matured. If you like this video, you're gonna have to subscribe. While we're spending all this time and money to create nuclear reactors, nature figured out how to do it all by itself. Check out Marin's video about that right here. Fun fact, thorium reactors were first researched with the goal of making nuclear-powered bombers in mind. The research was discontinued for what I hope are obvious reasons. Thanks for watching.